Okay, so that's what I mean when I say there's a simple graph with vertices V1 through Vm, V1 through Vm. Okay? And all I'm going to do is say that any traversal in V to get to W can be done once. Okay? So that's what K23 would look like. I want you to notice that I can't move from V to V. In other words, I can't move from this vertex to this vertex in one traversal. I have to bounce to somewhere in W to get back to V. Okay, so the only way that I can go from this vertex to this vertex is to go from here to another vertex and then back. Okay? Same thing with W, right guys? I can't go from W to W in one move. Okay, Ryan?
So the rule is, like, you don't have to worry about what's in the set itself, but all nodes in the left set have to connect to all nodes in the right.
That's exactly right. Exactly one time. Okay? And that's what complete bipartite means.
But I thought V only can have two edges, right?
Oh no! V can have as many as it wants. It can only have two vertices.
Oh, vertices, okay.
Right. It can have 100 edges if it wants to, or if it needs to. Okay, does that make sense?
Okay, yeah, I got it.
Okay.
Can you explain again the whole concept of just having it only connect to the other side once? Like,
Well, that's the whole definition of what it is.
Right.
Okay? Complete bipartite means that you can't move from V to V in one move. You have to make it in two.
There's no
Same thing with
V
W's.
to V.
Okay? You should not ever have this.
Okay.
Okay? That shouldn't exist. If it does, then it's not complete bipartite anymore.
Okay.
And guys, think of what bipartite means. It means two sets, and partite means separated. In other words, it's been a portion. Okay, that's essentially what we have right here. Okay? By the way, guys, in real life, this is an example of a password system. Okay, generally what happens is with a password system is that you have a computer. You want to be able to access something else, so you have to go through essentially a firewall. So in other words, there's going to be some sort of cloud that houses all the passwords. So you type in your password, this checks it, and then you're able to access something out. This is a fundamental data structure for encryption, if you would. Okay. Now, most of them are much, much more sophisticated than that. But I just want to make sure that you guys understand that this does have real-life aspects, just like this would. Like if you had a room full of computers, you would only want each computer hooked up to each computer once. You wouldn't want to have the same computer hooked up twice. It doesn't make any sense, okay? So, and I like the word that you were using before, nodes, which is generally how we use it in computer terminology. So if that helps you guys to think of it easier, that's fine too. Okay? All right, so any questions about complete graphs, guys? Really easy to kind of construct, not meant to be difficult. Okay. So make sure that you guys complete, I think it's assignment number 11. Okay, make sure you guys have that for me next time. I do have your guys' examinations and homework to give back. I want to end a little bit early, so I'll give it back. So let me give those back to you guys. And if you guys have some questions for me, let me know. Once you get your homework and your exam back, you're welcome to leave. I didn't post these on Blackboard, but I did great. So sorry about that. I didn't make you wait for it. Okay.
Thank you.
You're welcome.